So in this video, the last video of Unit 7, we're going to be graphing quadratic inequalities. So your only objective is that you're going to be able to graph a quadratic inequality. This is going to be kind of a combination of 7.1 and actually something way back in Unit 1 at the beginning of the semester. So remember, when we do inequalities, which we're referring to the less than, greater than, less than or equal to, greater than or equal to are your inequality symbols. We have two types of lines. We have dotted lines or dashed lines. Well, dotted lines and dashed lines get the less than and greater than. So for example, when we did this in Unit 1, we had less than, y is less than or equal to 2x, or y is greater than or equal to 3x minus 4. Could have been examples. Solid lines have which inequality symbol, which is the less than or equal to and greater than or equal to. So we could have y is less than or equal to 2x plus 1, or y is greater than or equal to 3x minus 4. After we did this, then we shaded the one side of the line or the other. If it was y was greater than or equal to, we shaded above the line. If y was less than or equal to, we shaded below. So just kind of review of Unit 1. This won't be on your work tomorrow, but just kind of make you familiar with it again. So graphing this, we had our M and our B. This is a line. We started up 5 and go up 2 over 3 as our slope. So we'd graph the line by plotting our points. Down 2 over 3, reversing my direction. So we get a series of points on our line. And then we decide, is this solid or dash? Well, since it is less than, it is a dashed line, so I just make dashes along my line. And then we would shade above or below. Well, y is less than. We're not eating y, so we shade below. We're going to do very similar to linear inequalities, except now with quadratics. So this is where 7.1 is going to come into play. So graphing this quadratic, we first decide whether or not it opens up or down. Well, it opens up because a is 1. Then we find the y-intercept, which remember the y-intercept is 0c. So that's 0, negative 3. We find the axis of symmetry, which is negative b over 2a was our little formula, x equals. So we go negative 4 over 2 times 1. That's 4 over 2, which is x equals 2. Then we can find our vertex, which the x-coordinate of the vertex is the axis of symmetry, because they're on the same line. And we plug in 2, so we go 2 squared minus 4 times 2 minus 3. That's 4. We did this in pieces to make sure we didn't make a mistake. 4 minus 8 is negative 4, minus 3 is negative 7. And then we can do our table of values. We only need 5 points total on our parabola. So we have 0, negative 3, 2, negative 7. So then I can plot my parabola, or my points to make my parabola. So my axis of symmetry is right here. So remember where my middle's at. So I have 2, negative 7, which is right here. 0, negative 3. Reflect that point over. Find another point that's somewhere around here. Looks like we don't have x equals 1, so I'm going to plug in 1. So that's 1 squared minus 4 times 1 minus 3. It's 1 minus 4 minus 3. Negative 3 minus 3 is negative 6. Okay. And there's my parabola. Oh. So, I kind of jumped the gun, and a lot of you guys are probably going to do that too. We have to look, because this is not just graphing a parabola. We have y is less than or equal to. Well, since it's less than or equal to, this does need to be solid, and I'm actually going to extend, keep going with my parabola to make it all the way up. You're going to fill the graph, even though you don't have points, try to make it bigger than we normally do. So here, y is less than or equal to. Since y is less than, I have two options. I either can go in the inside of the parabola, or I can go on the outside. Well, I need to be less than the parabola. Well, if I go in the inside, I keep going up, and I would keep shading up. So that is not less than. But if I shade on the outside, I get below the parabola. So that is less than. So you're either going to be inside the parabola or outside the parabola. So there is my solution. So let's look at example 2. This one also is going to open up because A is positive. My y-intercept, this is plus 0. So my y-intercept is 0, 0. My axis of symmetry, negative 4 divided by 2 times 2 gives me negative 1. X equals negative 1. My vertex will be at negative 1. So plugging in 2 times negative 1 squared plus 4 times negative 1. That's negative 1 squared is 1 times 2 is 2. Minus 4 is negative 1, negative 2. Doing my table of values. Negative 1, negative 2, 0, 0. Drawing my axis of symmetry at negative 1. Remember where in the middle of my parabola is. We have negative 1, negative 2, 0, 0. Reflect it over. Do one more point. Looks like I can do x is 1. So 2 times 1 squared plus 4 times 1 is 2 times 2 plus 4, which is 6. 2, 4, 6. Reflect it over. Alright, so now I'm going to look. I have y is greater than, and then we don't need to worry about this anymore. Y is greater than, so that means it's going to be dashed. So I'm going to extend my parabola up through the grid, because it helps with the shading. So y is greater, so I have two options. I have the outside, which notice I go below the parabola, or I have the inside, and if I would keep shading up and up and up and up, I'm keep going higher and higher. So that would be greater than, so I am this one shading inside the parabola. Alright, so the last example, so in this one opens down because A is negative. My y-intercept is 0, negative 1. Do my axis of symmetry, negative 6 for 2 times negative 1. This comes out to be x equals 3. Doing my vertex, I get 3. I'm going to plug in, so I get 3 squared plus 6 times 3 minus 1. That's negative 9 plus 18 minus 1. 9 minus 1 is 8. Table of values. 3, 8. 0, negative 1. 3, 8. And that's my middle. Let's do that in red. My axis of symmetry, so I remember where the middle of my parabola is. We have 0, negative 1. 3 away, so go 3 away on the other side. And find some value in here. I'm just going to do the next one over, which looks like 2. So I go 2 squared, negative, plus 6 times 2 minus 1. 2 squared is 4, negative 4 plus 12 minus 1. It's 8 minus 1 is 7. Plot the point, plot symmetry point. Alright, so looking ahead, I have y is greater than. It tells me my parabola is dashed. Make my dash parabola, fill the grid, help with my shading. Alright, so on this one, y is greater than. So I have two options. I have outside, which I shade all the way up here, and I'm shading above the parabola. Or I have the inside, which I shade here, and I keep going lower and lower and lower and lower and lower. So that would be less than, so greater than, would be on the outside. Alright, so that's it for the video. Graphing is the same as before. We have the less than or greater than, the dash line, or shading above and below, these two. We make a solid line. Right. You have to decide whether it's, so this kind of refers to solid or dash. Solid, less than or greater than, dash. And graphing the same before, remember the negative b over 2a, 0c, and plug in one more point, and that's 7.1. And then you're shading whether or not you're above or below the parabola, and you just kind of have to look which direction is going more up and which direction is going more down. Just a reminder to do a reflection so you get credit for watching this video.